Hello again, it's Mrs. Hoekstra. I am working on Module 1, Lesson 11, Ratios of Fractions and their Unit Rates. I'm on page 45 of our book. Lesson 11, Ratios of Fractions and their Unit Rates. I've got the essential question written in. How do you calculate the unit rate of a complex fraction? How do you calculate the unit rate of a complex fraction? Complex fraction. That's a new word, right? I'm kind of curious. I wonder what that is. What in the world is a complex fraction? What is that? Okay, so let's see what we get in example 1 here. During their last workout, Izzy ran 2 1/4 miles in 15 minutes, and her friend Julia ran 3 3/4 miles in 25 minutes. Each girl thought she was the fastest runner. Based on their last run, which girl is correct? So I need to figure out who's the fastest runner. Okay, I want to know who is the fastest runner. Well, let's keep track of Izzy's information, shall we? Let's keep track of that. So let's see here. Let's write down Izzy. And let's see here. In 15 minutes, let's keep track of minutes. And she ran 15 minutes, and then we can do 30. We could just kind of figure out a table, right? 45, 60, right? But you know what? When we keep track of speed, right, because that's what we're trying to talk about, speed is usually measured in miles per hour, right? We're usually going to measure it in miles per hour. So let's see. How much time is this? Right? 15 minutes is a quarter of an hour, right? You'd be like, oh, it's 15 minutes past the hour, or it's a quarter hour, right? 30 minutes is a half an hour. 45 minutes is 3/4 of an hour. 60 minutes is 1 whole hour, so on and so forth, right? And then let's keep track of the distance that she ran. And this table has seen better days, I think. And she ran 2 1/4 miles in 15 minutes. She ran 4 1/2, right? If I just keep that pattern going. Then she went 6 3/4, and in 1 hour, she could do 9. Wow, she's pretty fast. Well, let's do the same thing for Julia. Right? Let's do the same thing for Julia. Let's keep track of her minutes, her hours, and her distance. All right. And it says that she ran, what does it say? 3/4 of a mile in 25 minutes. So let's do hers in 25 minutes. 25 minutes, 50 minutes, 75 minutes, right? Like that. And 25 minutes, 25 minutes, and there's 60 minutes in an hour. If I reduce that, 5 goes into both of those, 5/12. So that's 5/12 of an hour. Yeah, nobody talks like that. That's kind of weird. 50 minutes, right? 50 minutes out of 60, that could be reduced to 5/6. So that's 5/6 of an hour. 75 minutes. 75 minutes is actually 1 1/4 of an hour. And let's see here. It says that she ran, 3 3/4 of a mile. 3 3/4 of a mile. And then I double that, and I get 7 1/2 miles. And then I add another, and it's 11 1/4. So I don't know who's fastest yet. Okay, I can't figure that out. So what I'm going to do is I'm going to calculate the speed for both of these girls, and let's see if we can figure out who is running faster here. All right, so let's work with Izzy. Izzy's speed, she went, well, we could make this kind of easy for us. She went she went 9 miles, 9 miles in 1 hour, right? We got that straight from here. She went 9 miles in 1 hour. That is her speed. She is a pretty fast runner. The question is, how fast is Julia? Is she faster or slower? What do you think? So I don't know. Which set of numbers do you want to take? You can take the 25, the 50, the 75. We can take any of these numbers. I think I'm going to work with this set here. Okay, I'm going to work with the middle set. I think I'm going to take the distance, 7.5 miles, and I'm going to divide it by 5/6 of an hour. Because remember, we're doing this in miles per hour. Okay? So if I take that, well, 7.5, I could rewrite 7.5. I'm going to just take those labels off. I can write 7.5 as 7 times 2 is 14 plus 1. That's 15 over 2, and then over 5/6. That's one crazy looking fraction, isn't it? It's a fraction inside of a fraction. Guess what that is? Yeah, that is a complex fraction, right? It's pretty crazy looking. Well, don't freak out about it. That fraction bar there just tells you divide. Just divide that. That's all that's telling you to do. All right? So you're going to take 15 over 2 and divide by 5/6. Well, I learned a little ditty, a little scene when I was a kid. When dividing fractions, don't be shy. Just flip the second number and multiply. So I'm going to leave 15 over 2. And I'm now going to multiply by the flip of 5/6, the reciprocal, which is 6/5. Okay? And when I calculate that, 6 times 15 is 90. And 2 times 5 is 10. Oof, I'm running out of room. 90 divided by 10 is what? 9. Oof. What do you notice? Yeah, these two girls won the same speed. They run the same speed. Neither one is faster than the other. If they went out running together, they could keep up with each other. All right, let's try example 2. A turtle is walking 7/8 of a mile in 50 minutes, right? Because turtles aren't walking very fast. All right, 7/8 of a mile in 50 minutes. To find the turtle's unit rate, Meredith wrote the following complex fraction. Okay, so let's write down a little definition of what I just kind of implied about complex fractions. A complex fraction is a fraction in a fraction. Fraction in a fraction. It's a fraction in a fraction. That's what that means. All right, and I'm not a fan of that fraction bar there, so I'm going to put this in a little stronger so we can see it. 7/8 on top, 5/6 on bottom. 7/8 in the numerator, 5/6 in the denominator. Well, where in the world? I know where the 7/8 came from, right? That's pretty obvious. Right there. Boom. But where did the 5/6 come from? Well, if I take this 50 minutes, and again, I want to figure this out for speed. I always do speed in miles per hour. So I got to take my 50 minutes and divide by 60 minutes in an hour, right? And that reduces to 5/6. Okay, so it's just the conversion of minutes to miles per hour. That's what I really want to get. All right, now how do I get my unit rate? So what I'm going to do is I'm going to take that 7/8, put it over that 5/6 that we were given. And I had just told you that that fraction bar tells me to divide. So let's just rewrite this as a division problem, because that's all it is, okay? That's all that is. So let's rewrite it as 7/8 divided by 5/6. But when you divide fractions, I'm not shy, I flip my second number and multiply. So the 7/8 stay, because I didn't talk about the first number, I talked about the second one, and I'm going to multiply by, now flip that, 6/5. All right, 7 times 6 is 42. 8 times 5 is 40. Can I reduce that? Yeah, I can reduce that. That reduces to 21 over 20. But I want this as a unit rate, so I want to divide everything by 20. Okay? How many times does 20 go into 21? Goes in there one time. Right? With one left over. Remember those little remainders? But the remainder I can put as a fraction. And so I actually get 1 and 1/20 miles per hour. So this little turtle walking down the path, it's going to take him, or he can walk 1 and 1/20 of a mile in an hour. He can walk 1.05, if you want to change it that way, miles in 1 hour. Of course, we know turtles aren't walking very fast, so that kind of makes sense to me. All right, exercise 1 I want you to do and try on your own, and then exercise 2 we'll do together. So go ahead, hit pause, and try this one on your own, and then when you hit play, I'll have that, and I will do exercise 2 with you. Okay, well, there's my answer for Anthony's birthday, right? Does Mom have enough flour? She doesn't. She has only 1 cup, and I calculated that she needed 1 1/3 cups. So I guess she's not going to be making cupcakes for his birthday, or she's got to go to the store and get more, right? All right, let's do exercise 2 together. And you'll notice this big table, right? Sally is making paint for which she is mixing red paint and blue paint, right? So she's making purple. The table below shows the different mixtures being used, okay? We've got all these different mixtures being used. It says, what is the unit rate for the values of the amount of blue paint to the amount of red paint? So let's calculate this, and it says blue to red. So they're telling us to set up our ratio that way. We're going to do blue to red. So go ahead up here at the top and let's calculate what's going on, right? I think I'm just going to grab this first one here because I'm super lazy. I don't feel like looking very hard. So that first one, blue, 2.5 over the red, which is 1.5. All right, complex fraction. So I'm going to convert that. So what you do is you multiply these two and add that. So 2 times 2 is 4 plus 1 is 5. So I've got 5, and you always leave it over the same denominator, over 2. Because if you remember, 5 divided by 2 is 2.5, so that makes sense to me. And then I'm going to multiply. 1 times 2 is 2, plus 1 is 3. 3 over 2. I don't know why my pen keeps dropping in crazy colors every so often. Sorry about that. So now, this is just a division problem, right? So I'm going to take 5 over 2 and divide by 3 over 2. Well, when dividing fractions, don't be shy. Flip the second number, so the first number stays, and multiply. And when I do that, I'm going to get 10 over 6, which I know reduces, right? It reduces to what? 5 over 3. Yep, 5 over 3. Okay. Or you could say 1, because 3 goes into 5 once with 2 left over, right? 1 2/3. There is our unit rate, okay? Is the amount of blue paint proportional to the amount of red paint? If I did that for all these problems up here, I would find that they are proportional, all right? If I go through, this is consistently the same purple every time, 4 over 2 2/5. I'm going to get 1 2/3. I'm going to get the same number every time. So this is proportional. All right, describe in words what the unit rate means in the context of this problem. So I've got this 1 2/3, but what does that mean? I'm going to use 1 2/3 quarts of blue paint to 1 quart of red paint. That's what it means in the context of this problem. All right, that's it for this one. I'll see you guys later.